So my name is Keith Molnau. I'm a major bridge projects engineer with MnDOT Bridge Office.
Yeah, my name's Chris Hoberg. I've been with MnDOT for about 15 years now, right out of school. Spent some time doing in-service bridge inspection, then moved into over to the bridge office to work with their construction unit, helping construction projects and scoping projects. Came back to Metro District and did some planning and programming work with bridges, lining up projects for our capital improvement program. And then I moved into what we call an area engineer role, a lot of local government liaison work and project management as well. So Third Avenue Bridge was a project that I was project manager for MnDOT. And yeah, and then in the last 16 months or so, I've moved over into construction and I'm out managing Third Avenue Bridge in construction now too.
Why was the Third Avenue Bridge of prominent historic and architectural significance and selected for long-term preservation by Minnesota DOT?
The Third Avenue Bridge, first and foremost, it's a contributing property to the St. Anthony Falls Historic District. So it's on the National Register of Historic Places as a contributing structure. It's also one of the first examples of reinforced concrete arch bridge in the state, and the last to use the Milan arch reinforcement. So there's a couple of engineering reasons as far as why it's an important structure historically. Furthermore, you know, the actual alignment to the roadway on bridge, the S curve, is another engineering reason why it's a historically significant structure. There's some areas of bedrock underneath the river that needed to be avoided with the foundation. So that's where the S curve comes from. So
can you describe a little bit what the Milan reinforcing system is and why it was used and why it's no longer used?
So this Milan system was patented by Joseph Milan over a century ago. And what he came up with was a system that you could rivet basically an arch-shaped truss and then use that to basically hang the formwork on, and that would reduce the need for temporary false work when you're trying to build an arch, you know, with concrete, and you get a concrete cure. So that was kind of the basis for it. I think several bridges were built using that method, and our Third Avenue Bridge is like the last major arch constructed in the Twin Cities using this Milan system, although it was built on false work. So you can imagine on the inside of this arch, rather than reinforced concrete, it has a lattice system of angles that are riveted together that become composite with the concrete. And, you know, it's unusual because there isn't any reinforcement. There isn't any other reinforcement in it. That is the primary reinforcement. So it's really in there composite with the construction. It can be used to help cast the bridge initially, but then it acts with the concrete once the concrete cures to help carry tension and things. Now in an arch, you have kind of balanced loads, so you typically wouldn't have an issue with that. But when you deconstruct an arch, if you don't do it kind of symmetrically and try to make an attempt to balance loads, you can create tension in various unbalanced configurations that we needed to really carefully analyze. So that's really took a lot of focused attention on the deconstruction to make sure that we weren't going to overstress these arches as they were getting deconstructed.
I mean, in the most rudimentary sense, and Keith, correct me if I'm wrong here, but it's an early form of steel reinforcement within concrete. So nowadays, of course, we'll use deformed bar. You know, the ACI 318 code calls out all sorts of ways to design concrete utilizing the traditional deformed bar that we have today. But back in 1914, 1918, we weren't working with deformed bar at that time. So this is kind of one of the early forms of reinforced concrete. The project working with, you know, deconstructing and reconstructing the bridge under this project, the arches are sensitive to that loading. And so we had to do a lot of engineering work with our engineer of record and our construction engineer to develop a sequence to take the deck off and take the columns off and put them back on that wouldn't create an asymmetrical load in the arch and induce damage during the work that we're doing.
Yeah, I think the key thing about the Milan steel when it was patented, I think it was with the intent to actually kind of build a little temporary bridge out of this arch-shaped truss temporarily that would be strong enough to then carry the concrete when you pour the concrete. And that was kind of the unique feature about the Milan steel. In and of itself, it was a framework that was capable of carrying load. Like I said, they actually did use it, but they also used false work when they built the Milan system. For whatever reason, they decided to not hang the forms and all the concrete on that load. So then that kind of left all of the capacity of that Milan steel available for carrying the arch load. So with modern bridges, the technologies have evolved to use reinforcement and tie reinforcement gauges. So it's just typically not used anymore that I know of. I think there's other ways, other technologies, and typically we use reinforcement or post tensioning rather than bearing steel angles in concrete. Yeah.
So a lot of what we like to do is to try and encourage our readers to use more technology, the latest technology, better technology, be more efficient. So could you guys describe some of the technologies you used on this kind of preservation project, and how might the choices have been different if this was a new design versus trying to preserve an existing structure? And just kind of describe the things that you used and why they worked.
Yeah, so I think the first one, a big overarching theme of this project for the Minnesota Department of Transportation, was the use of CMGC procurement. So with the constraints that this project has in terms of access, in terms of you're working in the urban core, so your project area is pretty tight and constrained just with buildings and different features, let alone the river that we're talking about and the lock and dam and the falls, and our ability to deploy a marine fleet being really diminished by just site constraints. I think the CMGC procurement process allowed us to bring a contractor in during project development, design development, and utilize their expertise to help us figure out how the heck we're going to get out here, how we're gonna most effectively prosecute the work that we need to do. And so that was a big one, was the CMGC procurement.
Could you tell me a little bit about more specific about how it works, and maybe run through a little bit of the process that you use?
Yeah, so CMGC stands for Construction Manager General Contractor. It's a procurement method like design bid build or design build, a way of procuring a contract. It tends to be more common in vertical construction than highway construction or heavy highway work. But it is a procurement method that MnDOT was provisionally allowed to use on like a number of projects. And then we have some reporting responsibilities back to the legislature about how those projects have gone. So it's an effective tool. I like to think of it as, I've used this analogy a number of times, but I think of it like a basin wrench. You wouldn't use a basin wrench to go work on your kid's bike or on the lawnmower necessarily, but when you need a basin wrench, you really need a basin wrench. And I think this was a really good project for this procurement method. We had access constraints, we had staging concerns that Keith has kind of alluded to, with how we deconstruct and reconstruct this project and not damage what's there. You got to be kind of careful about how you unload and load these arches in particular. So having a contractor and having the competitive portion of the procurement happen before construction, but in the early stages of design, allowed us to have the contractor's team alongside us through development of the project, so we could work through these access issues, these constructability issues, the scheduling, and it really was effective, I think, in providing us with some schedule certainty and some cost certainty. There's other things associated with capital projects like this beyond just developing a budget. We have federal reporting requirements, and if we're going to modify the scope or the cost of a project, that there are processes that need to take place to get those things codified in our reporting documents that are federally required. That's law. So, it's not just like we come into a 90% plan and we've got some changes and the cost changes. We can snap our fingers and say, oh yeah, we're going to update our document, our transportation planning documents to show this cost. If it's above a certain threshold, we have to go through a whole multiple month process, and that can then impact your letting, that can impact the costs that you're seeing. So it's a vicious cycle. So knowing going into the latter stages of design that we've got a fairly good handle on what we think this is going to cost was a big benefit of that process. That was tremendous. But it all again stems from bringing this contractor on board during design to help us work through access, constructability, schedule, and cost issues. Alongside that, you've got a competitive process that's merit or that's qualifications based and proposal based that you make a decision on before you've put your design package and your contract together. There are questions about whether or not you're getting a fair price. And so that the process also involves bringing on an independent cost estimator and an engineer's estimator to estimate the job in the same way that the contractor will at both the 30, 60, and 90% design stages. So we're getting information from independent cost estimators to help validate the cost that we're getting from the contractor in that design phase. And then once we've concluded the design phase, the contractor who was successful in winning the CMGC contract for that design process, they have the first opportunity to come to an agreement on price with the department. So that's where that cost estimating work alongside our design work helps to validate again the cost that we're getting from our CMGC contractor, that we're getting a fair price. LiDAR scanning was another one early on. We're dealing with a lot of the project development on this starts with record drawings, right? And of course, during construction, things change. So your record drawings have quite a bit of value, but they're not necessarily the end story. So I think establishing physical location of the structure and its dimensions through survey, and in this case LiDAR means as well, was another way to help refine our data and make sure we knew geospatially where this thing was located, what our dimensions were, and back checking our record drawings off of. So we use LiDAR quite a bit. I can talk a little bit more about, I was gonna speak to anodes and corrosion protection. You're dealing with a 105-year-old structure at this point. The arches, the Milan design, that's one of the features of the bridge that really defines its character and its historic significance. So looking at a bridge that is of that age and the arches are kind of the heart and soul of the bridge, we've got to figure out a way to protect those and make sure that they can serve well into the future. And really, we're committed to the long-term preservation of this structure, right? So I think we took a look at our strategies for corrosion prevention, corrosion protection, and we utilize quite a bit of anodes out here to try and protect that Milan steel and prevent deterioration in the future by providing that cathodic protection. So that was another piece of technology that we've brought into the project. Finite element analysis, is that something that you want to maybe take the steering wheel on, Keith?
Well, the analysis of the bridge was complex just because of the unknown state of stress that the Milan steel was in. So we decided to do this was kind of based on our peer review process, but we decided to include a second order analysis with the finite element analysis to basically try to capture the creep and shrinkage effects over time and try to predict what locked in stresses might be present in that Milan steel that would utilize some of the reserve capacity of that tension in that steel. So that was pretty unique to this project. And I think I think conservatively captured that so that we were confident that we weren't going to overstress the arches. So that was pretty unique to this. And I think that would have been different had it been a new bridge versus this bridge. We wouldn't have had that unknown of how much locked in steel we would have had. We probably would have used very similar analysis techniques with finite element analysis. The programs available are very sophisticated nowadays that can capture that. So maybe the primary difference is that we were locked in with the old bridge that had a lot of unknowns, including the geometry that we addressed with the LiDAR scanning, some of the locked in stresses, and then the deteriorated state of many of the elements of the bridge were concerning to kind of deconstruct and reconstruct it and then to make it last again in the future. So with the new bridge, we would definitely have some newer materials and levels of protection, levels of corrosion protection that we would include in the design that simply weren't present in this bridge. But there would definitely be some differences, but a lot of similarities had it been a new bridge. But definitely was complicated by the fact that it was over 100 years old and had been rehabilitated earlier and was full of a lot of unknowns that were kind of locked into the bridge.
So can you tell me what you learned from this project and what you can use from this in future projects?
Oh boy, I mean, there's a lot to learn, on a personal level. It's a big project. It's complex, a lot of different stakeholders. I think having access to the contractor and the CMGC process, close coordination with all the different groups that were contributing to the design. I think one of the biggest takeaways for me was, when you're working with project partners, it's not just MnDOT here. We also have other groups that are contributing money to the project. The city of Minneapolis is involved. We have utilities that are involved out here as well. Taking their outcomes seriously and treating them as if they're MnDOT's own, and really caring about what the cost for our partners is going to be, what they're going to get out of the project for what they're putting into it. I think went a long way in the process to keeping those relationships healthy. And when unforeseen issues came up, and there might have been a spike in materials that drove a cost increase for our partners, for them to know that we were taking their objectives seriously in this process, I think went a long way to helping us be successful when we came up against bumps in the road down the way that had a direct effect on them.
Part of the thing that I wanted to talk about, we haven't mentioned yet, is this brim modeling that came up, and this bridge integration modeling, where you model a bridge in 3 dimensions, and that was done by COE, or actually it's Finley before COE was before Finley purchased COE, but the modeling itself was set up for there was hundreds of stages when you're taking a piece of concrete off. And if you're trying to articulate that to teams of engineers that are trying to come to a consensus on the loading, it's a laborious process to kind of understand. It was very effective and efficient for teams of engineers to really visualize what the contractor was proposing to do. So this brim modeling proved to be really a useful tool during the design phase. I guess one thing that I learned was that we have a long way to go before it's going to be very useful in the construction phase, simply because we still utilize 2-dimensional drawings as our contractual means to, this is what the contractor is going to use. So I think if people are evolving into getting brim modeling going, I think we'll have to evolve to also use 3-dimensional plans as part of a project delivery rather than 2D plans, and make a 3D model contractual. I think there's a lot of learning from the foremen and field staff, oversight staff with brim modeling yet to really make it an effective tool during construction. But it sure was useful. Can't emphasize that. Between that and the CMGC project approach that Chris mentioned, those 2 things were really key to getting this project delivered.
I think you hit on it, Keith. Consensus building, right? Both within the project development team and externally. Consensus building was huge on this project.
The whole access issue on our project was really solved by getting the contractor engaged during the design. And it really became a design theme that we needed to design constructability into the project. And that was really we were only able to accomplish that by this CMGC contracting method to get that involved. So if states are able to utilize that, I think we've had a lot of success with that here in Minnesota. We have a program on our website that documents our process. It sometimes needs legislative approval for states to get that. But that was key. I think the brim modeling, again, was very key for the design teams to use. The one thing that I think that I would say on our particular arch reconstruction was that the concrete surface repairs, as the quantities grow and as they become more than maybe what you planned for, they can become impact, they can impact the schedule, especially in Minnesota when we have to allow for placement of the concrete in the winter, heating and housing. It can really delay things. So that was an eye opener how much some quantity overruns had on delaying the schedule. So we are a bit behind here. We are gonna finish the project, and it's going to be a successful project in the end. But that was pretty eye opening for me, and something I think it would have been nice had we planned a bit more aggressively on that. I would advise that you do that and carefully look at your weather.
Keith, hearing the things you're talking about really kind of, I think, brought it to a focus for me is risk management. You talk about access. Access was a huge risk on this project early on because it was going to affect so much of what we could do and how we could do it, right? But we knew that deploying a marine fleet out here in this area of the river with the constraints that exist just through the upper lock and dam being closed to navigation, which meant anything that we would bring into the river had to come from upstream, and we had to find a suitable site to do that, and ideally one that was going to be available for the duration of the project. Like, that was a huge risk early on, and we made a decision. We were going to go with the top-down approach because it really mitigated a lot of the risk of access on the river for us. But that brought about new items that needed resolution, as well as any decision we would have made at that point did. But it was, management of risk is huge. Concrete surface repair, we had known from the inception of this project that was a primary risk point for us. We can go out and we can identify areas that we think are unsound, but just like 100-year-old house, when you open up that wall, you don't always know what you're going to find behind it. And so that was a known unknown, but really aggressively tracking and managing risk was an important part of this project, and continues to be.
Advice I would say is consider tower cranes early on. We spent a lot of time trying to figure out how to do this top-down construction with heavy cranes on the bridge deck and trying to do balanced loadings. And we spun on that for quite a while. So those tower cranes planted within the piers, multiple tower cranes, kind of relieved the load from operating on the bridge. And while they're not very common to be used in bridge construction, very common in building construction, I think it's evolving. So I would encourage people to really consider that early on.
And then this top down with the cranes, I believe I read about this project. That was because you guys weren't allowed into the water. How might you have done it differently if you were?
Well, I wouldn't say we weren't allowed in the water. I would say just that's the stretch of river that we're working within. Again, we're literally right next to the farthest upstream lock system on the upper Mississippi River. So you get any farther upstream and there's no more locks. We're essentially at the head of navigation. And that particular lock was closed to navigation through an act of Congress in like 2015, right? So there's sister bridges downriver that utilized marine fleets, and they were able to they had some more flexibility with how they brought materials in and out of the project. They used more precast. For where we are on the river and the constraints that we had for access, we were certainly allowed in the river, and we've done work in the river on this project. But it became a challenge to get materials to and from where it is we needed to be. And so we had to utilize that top-down approach more aggressively. That impacted how the tower cranes were key in pulling deconstruction and reconstruction loads off of the arches, which were the most sensitive part of our structure. But at the same time, it meant that we had to take some smaller bites when we were picking things out. And so that had direct impacts on the schedule, how long it would take to do this project, because we have literally, millions of pounds of concrete that needed to be moved out and moved in. So, I just think that was access loomed so large in the decision-making of this project. And so looking at the risks on the table that we had on our register at the time, top-down approach, and I still think there's no way we could do this without doing a top-down approach with the access constraints on the river that existed. We identified what we wanted this project to be. I think understanding the service life extension, understanding the fact that we're dealing with a historic structure that we are committed to long-term preservation of, that played into a lot of decision making. But the team once we were clear about what it is we were looking to accomplish, the team really coalesced around it, and everybody pulled the rope in the same direction. And I think that was a big part of the success was the fact that we all had a unified vision of what it was we were trying to do out here, what the important aspects were, and we worked through our project development and our project construction accordingly. Just having a unified vision, and again, everybody pulling on the rope in the same direction was a big part of the success.